Good morning. It's actually kind of nice to see everybody here at 9 o'clock in the morning. There's a bunch of systems people here in the audience, I'm sure. And I kind of feel like the last time I've seen this many people, there was probably some kind of big event that was happening in terms of a outage, or everybody was awake from the night before still. There's probably some people here who are actually doing that today, but hopefully you're not. And hopefully you can actually pay attention. I wanted to take a moment here to actually thank Fernanda, Sabrina, and Andrew as well, again, for putting together this great program, second year that we're doing it. I think it's going to be a really cool conference. You guys are going to learn, hopefully, a lot of new interesting things, but also take some of those ideas back to your teams and back to your companies to figure out if you might be doing something different or could be doing something different. So, again, round of applause to them. Okay, so I'm going to start off with a short clip from a TV show that some of you may know. If you actually work and live in Silicon Valley, you may find it funny. Sometimes you might find it real. Hopefully, mostly just a little bit funny.
So, can you kind of catch me up on what you see as your role in the company? What do you do?
What do I do? System architecture, networking, and security. No one in this house can touch me on that.
Okay, that's good to know.
But does anyone appreciate that? While you were busy minoring in gender studies and singing a cappella at Sarah Lawrence, I was gaining root access to NSA servers. I was one click away from starting a second Iranian revolution.
I actually went to Vassar.
I prevent cross-site scripting. I monitor for DDoS attacks, emergency database rollbacks, and faulty transaction handlings. The internet, heard of it, transfers 0.5 petabyte of data every minute. Do you have any idea how that happens? All those YouPorn ones and zeros streaming directly to your shitty little smartphone day after day. Every dipshit who shits his pants if he can't get the new dubstep Skrillex remix in under 12 seconds. It's not magic, it's talent and sweat. People like me ensuring your packets get delivered unsniffed. So what do? I make sure that one bad config on one key component doesn't bankrupt the entire fucking company. That's what the fuck I do.
That's basically what I told him.
Yeah, so, it wasn't until Facebook, or when I got to Facebook in 2009, that I really had to answer the question of what do I do? It was a bigger company at the time than I had ever actually joined before. So these things actually mattered to some people. And I wouldn't really use a video like this to describe what I do, although if it existed back then, I probably would have used it because it's pretty funny. But like many of you, I've worn a ton of different hats. I've written code, I've installed routers and switches, I've set up systems, I've built big architectures, but generally I've done a lot of different things in my career. I've managed teams, I've been managed by good and bad managers over my career. I've actually reinvented myself as well 3 times in my career over the course of like the dot bust, the dot-com boom, et cetera, et cetera. And I've learned a lot of interesting things along the way, but the one key thing that I've actually learned is that you need to do and be whoever you need to be to solve the problem that needs to get fixed. It really doesn't matter what you know or what you don't know, as long as you're actually solving the problem that needs to be solved. So I'll start out with an anecdote of where I started my career back in the 90s at some point or another. I worked at an ISP on the East Coast, and we suddenly got locked out of our server room, and the core switch had actually gone down. We didn't have remote rebooters back then, like a lot of companies at that point, so we actually had to figure out how to get in there. So I looked at my boss, who was probably about my age or a year older than me, and said, what do we do? And he said, just figure it out. And so we talked a little bit about like calling a locksmith, trying to figure out if somebody knew how to pick a lock. All those things were just going to take a long time. So I looked at the door, realized that it was made of wood, and I said, well, let's break it down, right? Like we needed to solve the problem. Everybody's connectivity was down, so we just needed to be able to get in and fix the problem. So it took about 5 tries to kick down that door, and I realized two valuable lessons that day. One, it's really fucking hard to kick down a door if you don't actually know where to hit it and if you haven't been trained to do it. And 2, like you just have to get it done, no matter what. The business had a need, I needed to fix it, and I did what I needed to do to actually fix that problem. So my tech career actually started when I was about 9. I was gifted a TRS-80 Color 2 computer. I don't know if anybody here actually knows it. But it came with a whopping 4 kilobytes of RAM at that time, right? So imagine trying to actually do any work today with 4 kilobytes on your system. I learned how to program BASIC on it, and I actually had just seen Tron recently, so I decided, hey, I'll do a rudimentary version of the light cycle game. Pretty sure a lot of people have actually done the same thing. And I learned, even though I actually was in a third world country at the time with arguably less technology or access to technology, I was imbibing as much as I could and just taking up as much technology as I could from everywhere I could find it. So I ended up actually going to school to study computer science. But at the end of it, I really kind of realized that I was a little bit too ADD. I'm a little bit of a quick fix junkie. I don't really want to sit down in front of a computer and work on something for about 8 hours a day to only then realize what my work had been, what my work was doing. Back then, definitely, we didn't have things like MVC frameworks. There was a lot of overhead to actually starting up any kind of program, building it, running it, compiling it, et cetera, et cetera. So I decided that I was going to go down a different route, and that's where I started down on networking engineering. And so, what better way to quick fix? You configure a router, you plug in a circuit, suddenly you've got bits that are passing. That's a pretty nice feeling that you've actually accomplished something really quickly in a couple of minutes. So my background is technically in software, some in network engineering, and then systems engineering along the way as well. Systems engineering is definitely not something that any of us learn at school today, although some of us are trying to figure out how to do that in the future. But it's just something that you learn as a trade as you work, right? The next interesting thing that I found at Facebook was that people actually cared about my title. I honestly never thought about it in a small company. And most of you who actually work in small companies, it doesn't really matter what your title is. You just do your job, and somebody actually knows that you're doing your job. And generally, people come to you when they have to solve problems. But many people do choose to define themselves by their titles. Titles give you role clarity. They allow the human brain to actually make sense of something like an org chart, or actually figure out who to talk to in the company if you wanted to solve the problem that you have. But I don't define myself by a title. I define myself based on my actions. If those actions happen to be writing software, then I'm a software engineer. If they happen to be troubleshooting TCP/IP flows, then I'm a network engineer. If they have to be rolling out a new binary to the OS, then I'm a systems engineer, whatever it is, or systems administrator. At the end of the day, I think that I'm defined by my flexibility, not by my title. But again, I do understand that a lot of people choose to define themselves by their title, or they figure out from a company construct that they actually have to build titles. So I think there's a problem with titles. They can introduce bias. You could pigeonhole yourself into a role or expectation. If you come from a traditional IT operations background or a company that has that, then you have certain stereotypes that you've built or certain expectations that you've built out of that person and the work that they do. It comes with a lot of baggage, and at Facebook, we actually had a lot of baggage back in 2009, and I'll talk a little bit about what those things are. Some of it was self-inflicted. Some of it was just reasonable. We had software engineers that came from companies that had traditional IT operations, and they usually would build something, they'd hand it off to QA, and then they'd hand it off to operations that actually deployed it, run it, maintained it, fixed it when something broke, and only ever talked to QA or dev when something broke specifically. We also had a lot of people who were just overwhelmed. They were saying no a lot. They actually wouldn't want people to deploy some new version of software to production because they didn't know what the impact of that was going to be. And so a lot of the responses were no. So that wasn't working out very well. There were also a lot of people who were on call 24/7, and nobody else in the company was really on call, or actually didn't have a way to be on call. And so they used to carry everyone's pager, and they answered every problem whenever anyone showed up into IRC. Now, in some traditional companies, you might have a structure very similar to this. I'm pretty sure some of you actually work in these companies. Like I said, dev builds it, they hand off to QA, and then somebody signs off, and then they hand off to operations. I've actually never really liked this model. I didn't come from that model in the past, and I also think that actually it can introduce a lot of problems with that. Particularly if you have the assumption that you're going to have to actually hand off to ops, then it could also create walls between these teams, because you actually have a go-between with QA. And so if you ever never actually end up talking on a day-to-day basis with anybody on the development side, then you don't really understand what you're being handed. So it can, like I said, it can create walls. Sometimes we can actually create metaphorical walls that can bleed into the physical world. So at Facebook, like I said, in 2009, we actually had some baggage that was self-inflicted. When I first started, this was the sort of layout. I tried to do it on a presentation, but it's really hard. This was sort of the layout of where people sat. And you actually had to go through 2 different corridors to get to the operations team if you were in software engineering. It was flanked by a bank of conference rooms on top of it and off to the side. So you actually have to walk about 20 to 25 feet to just engage with somebody in operations. So I thought to myself, like, how do you build a relationship when you've got physical impediments that don't let you do that? So that was one of the things we had to fix. We had more self-inflicted pain. So when I was interviewing for the position at Facebook, I read a lot about the culture. They had some really cool videos about the culture and a thing called boot camp, where we still actually have it today. And basically, you come in for the first 4 to 8 weeks, And you learn a lot about what it takes to ship code at Facebook. You learn a lot about the code constructs, how we actually think about code in general, and then you learn a lot about the back-end infrastructure. And the idea here is that you exit bootcamp being much more productive and understanding a lot more about the infrastructure in a short amount of time. So my second week, I asked my boss, I was like, hey, when do I join bootcamp? And he kind of looked at me puzzled. He's like, why would you want to join bootcamp? And so he said, well, we'll go talk to the director who actually runs bootcamp. And I did. And he said to me, he's like, oh, well, no, bootcamp's only for software engineers. You're in operations. Why would you ever want to write code here at Facebook? Why would you ever want to understand what's actually happening? You're the people that we hand stuff off to, and then you run it, and then when it breaks, you type a bunch of commands on the keyboard, and then like everything magically comes up. Like, this is not what you do here. That made me really sad. We actually had hired some really good people in operations at the time, but I think that their skill sets were really underutilized. So we had that to fix too. So in 2009, we actually had a team named SRE at the time. And when I talk to a lot of people in the industry, one of the biggest problems that they have is trying to actually figure out how to define the role that they do. So again, we add labels and titles to it, right? But if you're building a team, you might call it SRE, you might call it production engineering, you might call it DevOps. By the way, like, please don't call your team DevOps. If you really think that that's a really good thing to do, come talk to me later. DevOps is really a practice. It is not a thing you do. You cannot define it in a sentence. And actually, I'd argue that most engineers anywhere actually practice DevOps. So if you are a DevOps engineer, you should probably talk to your boss about changing your title. Anyway, I digress here. So fully defining and building the organization and changing the perceptions and fixing some of the problems that we were having has basically defined the last 5.5 years for me at Facebook. So I'm going to talk a little bit about sort of that origin story and how we got to where we are today. Like Fernando said, Ben Traynor was up here last year talking a little bit about the keys to SRE and the keys to success. Like I said, we had an SRE team. It was actually built in the guise of the role of the Google SRE team. But Google had started back in 2003, or the SRE team started in 2003, and by the time I joined Facebook in 2009, they had about 6 years ahead of us in terms of like the function, the organizational structure, the work that they were doing, the way that they engaged with the engineering teams. So if you worked back then at Facebook or you work today, please don't try to answer this question, but can anybody take a guess at how many of these we were doing back in 2009? So if you guessed 0, you were actually right. Heck, if I actually spot checked some of these, there was just no way, that didn't work out very well. There was no way that we actually were going to be able to solve any of the problems that were on that list because we just didn't have the personnel, we didn't actually have the way of dealing with them, and we actually didn't have a way to engage with the software engineers on a lot of these problems here. So let's just say that we had a lot of stuff to overcome, right? But I honestly think that it was actually reasonable. Even though things just sort of like seemed really dire, the company had grown by leaps and bounds. There were, as soon as Facebook had opened up its registration to non-college campuses, there was very little that they could do to actually gate the growth. And the growth was incredibly hyper. I mean, I started at the end of 2009, and we more than tripled our user base in about 6 months. So like, there's just very little things that you can do to actually be able to handle that kind of growth. And they didn't care about whether or not we could hire people. They didn't care about whether or not we had operational discipline in our structures. They didn't care if things went down. They wanted to share their photos. They wanted to communicate with their friends, and they kept on registering. But the point of it was that in 2009, we were there. Like, we had to fix it. There was nothing that we could do in terms of like going back and looking at the history and being, saying, woe is me. Like, we could, if we had only done X, Y, and Z. We just had to actually move forward and fix those problems. Just a little more example of things. Like, we didn't even have an on-call tool to figure out who was on call. There was the centralized team, SRE at the time, sort of had a wiki or tribal knowledge to, call the cache, the developer that they knew who was building memcache whenever there was a cache problem. So effectively, that person was on call 24/7, and they were getting burned out pretty badly as well. Almost everything that we found out that was broken was after the fact. We didn't really have a good engagement with engineering. We didn't have a way to actually talk to them before products were being rolled out. It was just, basically everything was on fire, right? We actually even had an organized team, excuse me. The team was organized into 4x10-hour shifts across 2 locations. So surprisingly enough to me and a lot of people as I talked about it over the years, was that at any given time, we only had really 2 or 3 people who were watching all of Facebook 24/7, which was also like really scary, right? So with all that wasn't working well, it was clear to me that we had to change the composition of the team. We had to change the work that we were doing. We had to change how we were perceived inside the company, how we engage with the engineering teams. there was so much opportunity, but it was definitely going to be hard. So I wanted to try and distill sort of, if I looked at the last 5.5 years of our history, the top 5 things that I think really made a difference to how we actually work and engage today. So the first thing is that we had a team that actually wasn't doing what they were supposed to be doing effectively. They, like I said, they were firefighting all the time. They just didn't have the time to do that. And so what we did was we said, okay, we're going to split the team into 2. So we started hiring for a team called SRO, Site Reliability Operations. And then we also decided that if we could hire enough people in SRO to be able to take over some of the work that SRE was doing, then we have an organization that does a specific function, which I'll get to in a little bit. And then we'd actually put some of those new people into another team, some of the existing people into the AppOps team or application operations. And the idea here was also that SRO would become a feeder team for AppOps or other portions of the operations organization at the time. They would learn a lot about how to manage systems at scale, how to deal with disasters, and then they take a lot of that knowledge into those other teams. And over the years, we actually did make a lot of those moves, so I think that this actually worked out pretty well. AppOps, on the other hand, was a small team of 5 individuals trying to manage 13 different services. And just to give you a little bit of an example, like even in early 2010, we had over 10,000 servers for just photos alone. Thousands of servers. I read that wrong. We had about 3,000 or 4,000 servers for photos alone. And it was managed by one individual. And that person also had to manage another service that was probably about that size as well. So they never really had, because we all know that servers fail, they never really had the time to build the automation to figure out how to replace that server in production, what to do to actually add a new server in production. They had a bunch of wikis, they had a bunch of scripts that they ran, and generally they're like, okay, that works, like it takes me 5 minutes to do it, and then I'll move on to this next problem that I have. So I think early 2010, when we got together as a sort of staff meeting, at the time we had hired probably more than 5 individuals, I asked everybody if they weren't working on an emergency at that given time to please close their laptops so we could actually have that meeting, and nobody closed their laptops. So that was really what their life was like, right? And as far as the software engineers were concerned, AppOps was the team that people that you gave your servers to, and they fixed them when they broke, or they gave you new servers when you needed them. That was like the basic role of the function. SRO's charter, on the other hand, when we built it, was to actually do 3 main things. 1, firefight if necessary, keep the site up and running 24/7, watch the graphs if we needed to make sure that the site was working correctly, and then do whatever the fuck you need to do to actually get it up and running. Call whoever you need to call. Focus on automation of individual server break fix, because mostly we had just too much manual work to actually put a server into production or swap it in production. And then third, the purview was also to bring up new capacity. So we were growing a lot, like I said earlier, and so we'd bring up a lot of capacity and a lot of new clusters all the time. So we hired a seed team of 6 individuals, and once they were trained up by the SRE team, then we actually took over the function for SRE in Palo Alto, and we actually retired the name SRE and continued into our evolution of SRO. So in conjunction with retiring the SRE name, we picked one of the things that we knew we could change completely on our own. It was hiring, right? So we knew that the function wasn't actually the one that we needed, and we needed to change it. So the first thing that we could do is start hiring differently than we were before. And early on, there wasn't really there wasn't a really structured, organized way of actually evaluating people coming in. So we chose to do that. Software engineering teams had already done that, so we actually standardized on that, came up with real good questions for each of the individual components. We focused on 4 main technical dimensions. Do you know how to write software? Do you know your way around a Linux box, and can you troubleshoot problems? Could you understand how the application interacts with the network, and do you understand what networking protocols are? And could you figure out how to build big distributed systems? And then finally, there was like this intangible, right? Like the culture aspect of it. Could you help us change the perceptions? Could you push people to think differently about the way that they were doing things? And could you do it without being an asshole, which is also the really hardest part, right? So Jay Parikh, the head of engineering and my boss and one of my mentors, has this saying on this wall in his conference room. And to be honest, I didn't really truly appreciate this quote from Deepak Chopra until I actually had gone through some chaotic moments of my own at Facebook. And so he and I sat down a lot and talked a little bit about the sort of operations and engineering culture that we had at Facebook. And we realized that if we actually didn't fix something, if we didn't make it be more tightly close together, then we'd probably end up building your traditional NOC, somebody that actually escalates for you, does the work for you, and then you call them whenever there's a problem. And I didn't want to build a NOC. I had done that before in my previous history. I didn't like it. I didn't think it was the most impactful way of actually solving the problems for operations. So we did one of the things that I think actually made a really big difference is that he took over operations. So operations now rolled up to one of the leads in engineering, which signaled to the company that operations was part of engineering. It was now their responsibility to make sure that the function actually worked. It was mostly mine to make sure that we actually did the job. But the best thing about it was that he had my back. Whenever I had some radical changes that we actually wanted to push through in terms of how we engaged or the things that we did, then he would be the final backstop when a lot of managers or individual contributors would come to them and whine and complain about what we were doing. And he'd said, we're going to do this. These are the reasons. Go do your fucking job, right? So one of the radical changes that we made was to make the software engineers on call completely. And if I had to narrow down like the major changes that we made that really was pivotal to our success, it was definitely this one. When I started talking to some of the managers about it and the engineers, the reaction that I got was somewhat like this, right? Like, we knew that we didn't have enough operations people to be able to handle every service. So I started talking to some of them and saying, like, okay, we're going to have to figure out where we can actually put the people that we have today. And so we looked at the 13 services, and we realized that we were just stretched too thin across them. So we picked 6 core fundamental services that we thought, if these are not working and we are not making a good, and we're not doing a lot to make them better over the years, then Facebook probably will fail. So what we did is we pulled from all those other 7 services and said, congratulations, you now own operations for your services. And we bin packed everybody into 6 different core fundamental services. So clearly, when I did that, it didn't make me popular. I had a lot of really interesting conversations about that afterwards. And remember how I said earlier, like, we didn't really have good postmortems? So we had to fix that as well. So we set up a meeting that was actually like your typical blameless postmortem. I won't go into too many details, because actually I saw the agenda, and there's a couple of presentations that are about that today. So you'll actually learn about those. But at Facebook, when we actually have a big problem, we call it SEVs. And so we have the SEV review every week on Friday, where when we initially started, we just put together a core team of people that knew a lot about the infrastructure, or that knew a lot about how to build infrastructure. And we invited software engineering teams, or even some of the operations teams, to talk about any of the problems that they'd had the week before. And what we do is we discuss, try and figure out what it was that we were doing, learn from those mistakes like everybody does in these postmortems. And then sometimes we'd actually armchair engineer some solutions. And it was actually really good. Some of those solutions did end up making it into production. A lot of them actually did. And a lot of teams actually find the value in this discussion, because it's just an open and honest discussion about what the problem is and what we should do. And again, the nice thing about this is that we had Jay in the room who could actually then say, okay, if we don't have enough resources for this, then we need to put more engineers on this problem, which is really great. I think from an architectural perspective, this has been one of the best programs that we've instituted. But I want to be clear, it's not an architecture review. It is an open conversation about what's going on, and then we still actually depend on the teams to make their decisions for them, because they know what the priorities are, they know what they need to be working on, and then they just let us know whether or not it can become a priority for them. We actually put this this slogan on a T-shirt and handed it out to everybody in infrastructure as well, because we really wanted to signal that the idea here wasn't necessarily about whose problem it was, but that we just needed to fix the problem, and that's what we were all focused on. And AppOps actually did get one major thing right. They were already embedded into the software engineering teams. They actually attended their meetings, they went to their offsites, they talked about their architecture. So in that sense, I think this was also one of the key things that set us up for success. If we hadn't already had that, we would have to introduce it. And so for some of the teams that already had it, they kind of understood that there was somebody who had a focus that was on availability, reliability, scalability, operation of the service, that was going to be part of their team, and they were sort of going to tell them, like, okay, if you do this, it's probably going to fail in this way. What are we going to do about that? So now that we had the coup of sort of handing over on call to a big portion of software engineering, then we began the next phase of our history here, which has lasted about a little bit over 3.5 years. But the real focus of that initiative was basically to think about it as if we didn't need operations in the company, right? We didn't need an operations group in the company. So how would we do that, right? So I'm going to talk a little bit about how we scale operations into engineering and how we enable every engineer at Facebook to actually do operations. So it's clear to me over the last few years that with the rapid adoption of DevOps, or the concept with a lot of companies, that the previously held ideal of having a separate operations team no longer holds true, right? More and more companies actually want and need a nimble way to be able to run their infrastructure. And so really what it comes down to is, why not use the largest portion of your technical organization to actually solve that problem? And most companies, that largest portion is software engineering. So invest in making sure that the software engineers can actually run operations. So scaling a rapidly growing site like Facebook still requires a lot of tools and focus on tech work. So I'll talk a little bit about some of the tools that we've built over the years. And really, when I say sort of operations of the site here, I mean the function, not the organization itself, right? Because even though software engineers actually think that they write code all day long, a lot of them still actually do operations. The traditional ops model has a lot of people doing a lot of manual work, right? So the first thing that we focused on was actually doing automation. Humans make bad robots. Everybody probably knows that. They make mistakes, they need rest, they require guidance, nurturing, and development. They're humans after all, right? But they can't do the same thing over and over again without getting tired. And so what we needed to do is we needed to invest and make sure that the computers could actually do the work that we would do. So our first two focus areas were on building that automation to handle the individual server break fix, but also to be able to bring up capacity really quickly. So FBAR is the name of the tool here that we created that handles the general case of removing a broken server from production. It's a set of libraries and functions that understands all the intricacies of what it would take to remove a server, add it into production, but it evolved over time to be a job engine. You could actually do pretty much generic things. And we've been able to actually standardize on a couple of back-end systems that then the operations teams could write functions to against those APIs to be able to solve those problems without having to have a human actually do any of it. From an impact perspective, I think this automation tool was SRO's best tool. They wrote a lot of different tools, but this one is definitely the one that has changed the way that we actually do operations. And really, the idea here is just to automate away the human and what they would do, right? Many of us have actually fixed issues by restarting services. When in doubt, reboot. That's definitely something that everybody does, right? And so this is just this one simple implementation of that tenant. And basically, if a human could actually log onto a system, see if it was up and running, try to restart the service. If it wasn't, try to reboot the server, see if there was a problem, or try to figure out if the software was missing. Like all those things, we can just automate those away. And it's done. It could definitely introduce a lot of problems, and it has over the years, because you could have a bunch of services that are just restarting all the time, and nobody really knows what's going on with them. So the FBAR team has iterated over the years in the development, and they've added things like better rate limiting, or they've added understanding of recidivism so that they could actually find services that were causing this problem. And then we raised that directly to the engineering teams. And when I last checked last week, FBAR actually did the equivalent of 13.6 thousand human hours worth of work in one day. Now let that sink in. He's on our team here, so. And I want to be clear, we don't have that many problems on the infrastructure every day, but like I said, it's been a generic job engine, and so people have actually adopted it to do things like kernel upgrades, right? And the basic idea here is that if there's anything that you have to do that requires you to deploy some new thing, check it, redo it if it failed, try to restart it, wait for it to restart, then check it again, that basic idea and function can just be handled with FBAR. We don't need a human to do that work. So that's how we come up with that really big stat. One of the other things that was painful was turning up new clusters. I remember in 2010 talking to our capacity engineering and analysis team about the clusters that we were going to turn up in the next year, and they said it was going to basically double. And at the time, it took us about 6 to 8 weeks to turn up a cluster, and it was a lot of manual effort. There was a wiki that we followed that we actually documented to do that. There was a lot of discussion with engineering teams about the thing that I tried to do just broke, what do you do about it, and how do you fix it, and then we'd have to wait for that to get fixed. So it was pretty manual. And so what we did was we focused on building a new team called Cobalt. And we tasked some engineers to basically build up a better turn-up service. And what we would do is build a set of libraries and functions that actually understands the interdependencies of every service that is required to come up to be able to turn up a front-end cluster. And it would stop and wait until that service was up and running, and then continue on forward. This is the dashboard of all our clusters and all our services. It's not all of them, it's just some of them. I couldn't fit it into the really big screen here. But it sort of shows us the current state of what those services are in each of those clusters. The red line that you see across the screen there is because we're actually decomming a cluster. And so all the services in that cluster are failing, which is exactly what we want to see. And the purple line is actually just a different designation for a test failing rather than the service itself failing. So we have to fix that test. And like I said, we scale our ops function through automation, but another way is through targeted tooling and better instrumentation. And again, when I talk to a lot of the people in the industry that have problems gaining empathy for the work that they do, a lot of times I ask them, do the software engineering teams understand what you're doing? How do you actually present that data to them? How do they actually understand what your day-to-day looks like and the stuff that you're working on? And a lot of times they say, oh, I've got this tool over here that I use, and like it's this graph, and and I said, does the software engineer know about it? And they said, no. And I said, why? Well, because I have a password on it. And you're like, well, why do you add a password to it, right? So what we do is we arm everyone with as much information as we can so that they can troubleshoot their own services. They shouldn't have to come to somebody who knows what they're doing to be able to understand that there's something wrong or broken in their system. So some of the tools that I'm going to talk about here focus specifically on operational items, and they are mostly exclusively written by quote-unquote operations people. And when your infrastructure gets big, it's understanding what happens is kind of like an X-Files investigation, right? There's always unexplained phenomena. You follow a clue, you think it takes you to another clue, and then you think you're going down to your root cause, only to realize that that was a dead end, and then you have to unwind everything and actually start over again. So one of our core values that we have at Facebook is to be open and transparent, and so we take that to all our tooling and our instrumentation to make sure that you can, if you're a service owner, you can actually troubleshoot it, or if you're an operations person, you can troubleshoot it as well. And it all starts with just a simple log line of data, right? We need to understand what's happening in production, and we can actually ship all the data back to our centralized database storage. One of them is called ODS, or Operational Data Store. And that one, just to give you an insight right now, logs about 83 million data points per second, or about 5 billion per day. So there's definitely a lot of data involved here, and this is just one example of the PHP implementation of it. We also have another service that runs on every server at Facebook called FB303. And at its core, it's just a set of thrift functions that most services implement. But there's an agent that runs on every server, aptly named FB agent, that collects all this data and ships it off at 1 minute and 4 minute intervals. But the nice thing about it is that we can actually query it real time. Even though we couldn't actually do completely real time in a centralized way, if we actually decentralize our stats, we can actually look at them and query each of those individual servers. And so we've written wrappers around the API that runs on FB agent. So here's for example, an example of that, where it's just basically like your top function in Unix. We actually just give it one metric, and it goes out to a list of servers that you give it, and it gives you basically an FB303 top. And it allows you to understand some of the outliers. You can sort it if you wanted to figure out which server was actually causing problems or not working as efficiently as another, you could. So it really gives you a lot of really quick insight into a bunch of servers all at once. That turned out well. Everyone knows this style of graph, right? Everybody's been able to see something like this before. This one specifically is our P99 latency across our web tiers and across our API tiers. But the problem with this graph is that it's really hard to disambiguate the blue line from the purple line, or the red line from the magenta. I think magenta is like a red, right? Anyway, so what we did was we implemented a different visualization to this. And we said, we implemented the Cubism JavaScript library that Square actually developed, and it gives us a really good way of debugging problems. So here's the representation of that same data. If you don't know about Cubism, this actually definitely looks confusing. So if you want to learn more about it, come and talk to me later on. But if it does make sense to the trained eye, then you can actually see that the problem is really happening in our API tiers only. It's not happening in our web tiers. You can also really quickly see that it's not happening in our Lulio data center. So even though it actually doesn't give you the root cause, it gives you a really quick way of understanding which direction you should take to solve your problem. We also have a common library that services can implement on the back end called Service Router. And basically, it's just a load balancer that you can implement that shares a lot of state between all the different servers that it's running on. And the nice thing about it is that if you do implement it, it reports all kinds of errors. From the client, it reports errors that it received from the server. And it allows you to actually understand what's going on. So we built a tool that where you can actually just input, if you highlight Cubism back on the last screen, it actually allows you to see all the errors that are coming from the web tier, from the individual services, and it can also correlate a lot of other interesting data. And here what we did was we actually aligned every different graph on the same timeline, so we could actually see really quickly, if you understand what this tool does, you can glance at it really quickly and understand that the service that this one had a problem with was running out of CPU. So again, it doesn't really solve the problem for you immediately, but it tells you that now you're narrowed down to the service itself. There's nothing in between that's actually causing the problem. The server is just running out of resources, right? Early on, we used to have a representation of a graph that looked like this to tell us whether something was wrong. And at some point or another, most people have actually implemented something like this, and it makes sense at a certain size. But after a while, the information is so dense that a human can't actually make heads or tails out of it. So we decided to invest our time again on visualizing it in a different way. The other thing that we like to do at Facebook is that we put our problems up on monitors so everybody can see them. And so we implemented this heads-up display. which again is another way of representing the data, but it really quickly draws your eye to where the problem is. You can understand whether something is healthy or not healthy. It's got pretty colors that everybody can understand is, green is good and red is bad, and somewhere in between is sort of bad, right? And it's also something that we can put up on monitors, which is easily then seen when you, say, take a coffee break or take a bathroom break and you come back and you're like, oh, is my service healthy or not? Hopefully you actually have alarms that are telling you whether your service is healthy, but this is another way of actually looking at that. And then another thing that actually generally causes companies to slow down is the rate of change across the infrastructure. I've seen this time and time again where teams and companies hit an inflection point where at some point or another, no human can actually understand everything that's happening on the infrastructure. And so they go down these weird paths of creating change management boards, architecture review boards. All those things generally actually I've seen only slow down a company. So at Facebook, we took a different approach. We created a centralized ops stream of all the changes that were happening for all the tools that we use on the back end, or even anything that you may be writing that then reports all that data directly into one location. And the nice thing about it is that if we do actually find a problem, we can go back and look at it. We have the time when something happened. We have the system that it was doing, and we have the individual who did it. So we can actually do two things. We can either go back to that system and roll it back. Hopefully it has a way to roll it back easily. Or we can talk to that individual and say, hey, what did you do? We think that this is causing a problem. The other nice thing about it is, with everything, you write an API on top of it. And we can actually overlay a lot of those events into a lot of our graphing infrastructure that we have today. And so we can also then hover over that little data point on the bottom that basically then says, OK, here's what happened. And you can try to correlate whether that event may have caused that problem or not, or you can try to rule it out as well. It's generally actually very useful. A lot of times we actually do find problems. Sometimes we have false positives, but generally it's actually been really useful. The other thing that I also think that is really interesting in how we do is that we open up our communications with problems. We actually blast the whole engineering team when we create a SEV inside infrastructure. If there's a problem that's big enough that we think everybody should know about it, we send them an email. We actually put in a new line into IRC. We let everybody know that there's something. We page a bunch of people all at once. And we tell them, hey, there's a problem going on. And if you could jump on an IRC to help us out, that'd be great. And it just generally actually shares this information with them and tells them there is a problem. Maybe if you see something on your side, it could be this. The other thing is also it prevents a lot of people from just jumping onto IRC and asking, hey, is there a problem in Prineville, which is what PRN here stands for. You don't actually have to answer that question because they can just look at this tool and say, oh, yeah, there's a problem in Prineville. Here are the people who are working on it. And then the other nice thing about it is it records the history and the communication. And if you actually paste any kind of graph into it, it actually gives you a screenshot of it on the right-hand side. You can click on it and you can see a screenshot graphic of it, or you can actually take you to that actual graphing system on the back end so you can actually do more granular stuff. And it tells you everybody who's working on the problem at the same time. So again, when we go back to our postmortems, we can just look at this and it's easy for us to write an incident report and understand what was going on. All right, so up to now, I've mostly been talking about localized organizational changes or tool enhancements that happened over the last few years to help us get everyone thinking about operations, right? And those are for sure really important things that you need to do, or that we needed to do at the time, to be able to actually operate our services at scale. But nothing really changes if you don't change the way that operations is seen inside the company. If you don't actually focus on changing that perception or changing that stereotype that you might have fallen into, then you're still going to actually have the threat still exists of a lot of software engineers coming to you and saying hey, why don't you run my service for me, right? So the next part of my talk is going to talk a little bit about how we accomplish that goal. So remember how I talked about how titles could be bad? So application operations actually had ops in the name. And it's amazing how, again, this really affects a lot of people. And so we had new and incoming software engineers who still thought that operations, because it did the same thing that they did at their last company, they ran my services for me. So no matter what we did, no matter how many tools we built, no matter how many conversations we had, that stereotype just wasn't going away. So we decided to change our name to production engineering, thus dropping ops from the name there. And this signaled to the company that we were an engineering team. We were writing code, we were building tools, we were working on scalability alongside with the software engineers. And over time, we believed that new engineers, enough of them would join the company that they would forget about the ops part of the job that we do. And overall, actually, that has been happened. But at the same time, we wanted to signal even internally to our teams that we wanted to bring a little bit of that, you should be acknowledged for a badass with a unique set of skills on your team that actually knows how to solve problems at scale. And this was another way of actually presenting that. And hopefully, if we gave you the expectation, you'd actually step up to do it as well. SRO, on the other hand, had a different problem. For years, they actually did a really good job. They focused on fleet-wide automation. They solved some of the big capacity turnup problems that we had. They kept an eye on the site and reacted really well when there were problems and marshaled all the people that needed to fix it when things went wrong. And as the years progressed in infrastructure in general, we solved a lot of common problems, or common pain points, mainly things like deploying systems to production, replacing individual servers, or the monitoring and instrumentation of it. But the size of the infrastructure got so big that one centralized org could no longer manage state. They couldn't understand the intricacies of these services. And in fact, what ended up happening is that they got to a point where they were scared of making any change because they didn't understand the ramifications of what it could be for that service. And a lot of times they did make a change, and it did go badly. And so then we actually started to introduce a lot of gun shyness to people. They didn't actually want to pull the trigger on those changes. So we realized that SRO had outlived its usefulness, and we focused our energy on removing this org completely. And this was the reaction I got from engineering. So this is the second time that in my history there where I announced plans that we were going to do, and I got this kind of reaction. Whoa, what are you doing here? We could have actually gone down the same path before, like building another organization, trying to figure out what the old one did and deprecating it over time. And that was going to be a long time. But we decided instead that what we would do is we would actually just rip off the Band-Aid. And we spent the last 12 to 18 months doing that. And the last 6 months of it was actually the most critical, where what we ended up doing is that we took a data-driven approach that I'll talk about in the next slide here. But when I started talking with the engineering teams, to be honest, even I had some hesitation, right? I wasn't sure what was going to happen. Questions were coming up like, what's going to happen at 3 o'clock in the morning when nobody's awake and can't see that the site has gone down? How are we going to actually, aren't we going to lose a lot of that tribal knowledge that SRO had about contacting people and or fixing those problems at scale? And those were honest questions to be asked, and I didn't know all the answers to them at the time. But I knew that it was the right thing to do, because mostly SRO had become a crutch for the engineering teams, and it was also becoming a crappy job, and nobody really wanted to be in that job anymore. So, like I said, they did provide a lot of primary on-call support for a lot of teams. So what we did was, early on, we instrumented the work that everybody in SRO did. If you SSH to a box to try and fix it, we knew about it. If you acknowledged an alarm in our centralized alarming system, we knew about it. If you talked to somebody on IRC and used a specific keyword, we knew about it. So we had a really nice, we just used our own graphing libraries, and we had a really nice way of understanding where we're spending most of our time. And so what we did was we systematically went through every team that was causing the most amount of pain and talked one-on-one with them and said, okay, why are you not using FBAR? Why don't you have better instrumentation? Why are your alarms not as clean as they should be? What do we need to do to make sure that we can actually solve this problem for you as well so that you can run your own operations? And over time, we iterated on this and we got better. But towards the end, and in the last about 2 months or so, what we did was we beta tested this with a couple of different teams. We said, okay, now we think we're actually at a point where you can run your own operations. Go do that. Software engineering and production engineering teams can run their own operations. SRO is no longer primary on call. But what we did was we watched. We kept an eye on things in IRC. If things went south really fast and the SRO team knew how to fix it, they fixed it. And then they'd go back to the team and say, okay, well, here's what we did. Why don't you know how to do these things? And over time, again, we just iterated on that and got to a point where we actually were able to pull the plug in March 31st of last year. So that was a really good win for us. Okay, so now we've gotten rid of the centralized team that does primary on-call. We've also adopted engineering title for all our application operations engineers. But that's not really the end, right? We still have to make sure that the embedded person in the software engineering team that technically does quote-unquote operations doesn't just end up becoming the ops monkey again, right? You can have a lot of developers who just say like, oh, well, that is your role. Why don't you just do this for me? And we focus a lot of our time and engagement on making sure that that doesn't happen. And generally, we're pretty successful at it. But it's definitely something that's ever evolving. And in order to do it effectively, we need to think a lot about what the role is and focus on the impact of the work that the individual is doing. If the individual actually falls easily into that stereotype on their role because they're doing something for somebody else all the time, then that's not going to be a good thing for us. So we need to make sure that we evaluate them that way. So one of the questions that we get asked all the time is what is the role? What is it that you do? How do you engage with the software engineering teams well? And it's actually a really hard question to answer in, say, a 2-minute conversation or passing in the hall or in a meeting that I'm in. So one of our engineers actually focused on coming up with a framework or model that makes sense to describe the type of work that we do and the type of engagement that we have with engineering. And the nice thing about models is that it gives you, if you know a model in the wild and you can compare it to some work that you're doing today, then it actually makes you understand that problem really quickly. So the first thing that we did is we implemented a maturity model that allows us to evaluate how well things are going for the service teams in production engineering or software engineering. It's not a rigorous model, but it really gives us a good frame of reference to understand whether or not things are going well and whether the work that's being done is appropriate. So we think about sort of the maturity of the service and the team in three different stages. In the first stage, and most teams will actually go through these three different stages. In the first stage, we really focus on bootstrapping the service. Getting the servers, making sure that they're healthy, making sure that you know how to put new ones out there. From the software side, maybe you have a small number of users, maybe they're beta, you're starting to try and figure out which features you're going to add to your service. And generally, it's a lot of firefighting, but also a lot of quick iteration on that. And then it takes you to the second stage, where you're focused a lot more on making the service work in production better. You're scaling it out. You're having better instrumentation to understand failures. You have better canary systems and deployment systems that allow you to do stage deployments of the service. On the software teams, you're building new features as you figure out what the onslaught of users is going to look like, and then you figure out how to do things more defensively. And then in the last stage, once things are more stable, then the teams work on making their service a lot more awesome, dealing with things like outliers, the last 5% of requests, making them respond as quickly as the first 95% of the requests. The nice thing about it is that if we look at this on a continuum across both teams, if we have the software engineering team focus on the last 5% of their services, but we've got the operations team or the production engineering team focused on what it means to bootstrap and scale the service, then it's lopsided, right? They're not working on the same thing. They're not actually paying attention to the same thing. So we can quickly look at this model and say, hey, there's something wrong here. We need to fix this. We can also look at the relationship status of the teams. Perhaps that's why it's lopsided. We evaluated along sort of like three main areas. One is that it could be contentious. The SWE and PE teams are at odds about what needs to be done and how to do it. And if for whatever reason they're stuck in this mode, then more than likely that engagement is not going to be successful in the long term, and we have to have a different conversation about the fact that we're going to stop working with them, right? And that usually actually brings everybody around. It could be orthogonal. The SWE and PE teams are not collaborating on projects or really amplifying each other's work. They're just doing different things. They're not actually in conflict, but they're not really actually focused on the same goal as a team. So again, if you're in this mode, maybe there's going to be something wrong in the future. Maybe you'll go down the contentious path, and we actually have to fix that as well. Or there's the synergistic one, which is a nice buzzword that I never thought I'd actually use, but I did, where each team really complements each other's output and enables them to produce a lot more in concert than they would actually produce individually, and so happiness abounds. Now, when you're trying to figure out what type of work you're doing and how you should prioritize it, this is also a difficult conversation to have. So again, we tap into the idea of taking a model in the wild and applying it to the work that we do every day. Some of you may be familiar with a psychologist named Abraham Maslow that proposed a theory in 1934 that describes sort of the stages of human growth. And it's represented in a pyramid like that. And basically, you have your more basic needs on the bottom, and as you traverse up the pyramid, you get more complicated. But the idea is that it's a good representation to understand what's necessary. If you haven't solved the problems at the bottom of the pyramid, you can't really actually get to the top of the pyramid. Or at least that's what his theory is. So we apply that to our services and the work required. And this is what it looks like. The specifics of each individual service may look slightly different. Some of them may actually be a little bit more further ahead when we get to a point. But again, if we look at the maturity model of that service and the team, then we can understand that you shouldn't really be working on the 1% stuff if you haven't solved your basic server monitoring lifecycle, right? All right. So I talked a bunch about a bunch of things, but what's my point here? I'll try to summarize it a little bit in a couple of different points. You need to figure out your role, the role that you need to play within the company, and just execute on that specific thing. Get good at that. You need to align your team behind the role so that everyone knows what you're supposed to be doing. You need to make sure that you don't become a single point of failure, because a single point of failure can actually slow down the company significantly, or even your team just locally. You also need to teach everyone how to fish. Let them do your job for you. It's not your job to do it for them. And then at the end, you can sip tequilas on the beach if you solve that problem. So, thank you, everybody. That's all I had to say. So I think we have a few minutes for Q&A. We actually have mics on each side here. If anybody wants to come up and ask questions, please come up so that your question can be recorded.
Data center build-outs if you don't have an SRO group?
Yeah, so the physical side of it actually is the data center operations team. So they do the physical rack and stack We have an integrator that actually gives us a full set of racks. We just roll them in, we plug them in. The only thing we have to do is plug in fiber. And then the Cobalt system actually does the automation aspect of turning up the data center. When we're turning up a new region, that's the only part where we actually have a lot more humans still engaged, because turning up a region still requires a lot of instrumentation and work that we need to change over time. So we actually have a team that's called the CSI team, I think is what it's called. Yeah, and they actually sort of focus on cross-data center traffic, things that we need to understand when we actually build out new regions. And so they're the ones that run that program. And then we have a small team of people in our cluster ops team that actually that maintains Cobalt. So,
Thank you.
yep.
You had a great number with respect to how much time was saved by your FBAR. And
Yeah.
I'd like to know what you used to measure the people time that you were saving with it.
Oh, I think it's actually really dead simple. It just actually adds up the number of minutes that it takes to run a job. We don't actually do a lot of trying to figure out like what it would take for a human to type that command in instead. It's just literally linear time.
Thank you.
When putting devs on call, were there any concerns around attrition among those teams?
Yeah, totally. Yeah, there were concerns around attrition. A lot of them mostly complained and said like, hey, that's not my job. Like, why do I need to do that? And some people actually did resign or leave the teams because they didn't want to do that role. Over time, what we just found is that the more and more software engineers that were on call and managing their operations themselves, they became stronger software engineers because they could actually understand what was happening in production. They actually understood what their algorithm was supposed to do, and then they could see what it was actually doing in production. So it made them a lot stronger than defensive programmers. I think you were next.
Hi, thanks. Great talk, by the way.
Thank you.
So there were at least 2 times where you made really big announcements, and I was wondering, how did you gain momentum so that, within management, so that by the time you got to that announcement, there was support all around?
That's a good question. Yeah, lots of conversations. So initially, in the beginning, when I started talking to some of the software engineering managers, I did get really bad reactions, and mostly they thought I was crazy. But over time, I just sort of like continued to talk and be on point and actually make sure that I just said the same thing over and over again. And if you do it 1,000 times, people will actually get it. But I also iterated on their feedback, right? Like they actually brought up really good points of things that wouldn't work. And it actually required that we do something different to make sure that we solve that problem. But in the beginning, it was definitely like a pretty difficult conversation. I think you were next.
You talked a lot about applications and server integration, but didn't touch anything on networking. So always looked at like the application layer or the server infrastructure is something wherein you could easily fit into an SRE model or a DevOps model, even though you hate it. But how do you plug in your network infrastructure and still follow the same model?
Yeah, so there's a portion of networking that probably can never be automated. You actually have to plug in a physical cable to do something, right? Like that's something that we've actually realized that can never probably be automated until we actually invest a lot into robots, and maybe that will happen in the future. But I don't know if you've heard, but from a company perspective, we've actually started working on our own switch, and it's through the OCP model. It's called the wedge switch, I think is the external name, maybe not. But basically, it's running it as a server. It is basically a Linux OS that has a lot of APIs, and we're actually integrating a lot of our operational workflow into those switches, and so that way we can actually manage them remotely, just like if it would any server. And so the network engineering team has a component of its organization that is focused solely on automation. We actually have one of the engineers here if you guys want to talk to him later about it. But, yeah.
Yeah, great presentation.
Thank you.
And I think that it really resonates that, removing the walls and not making QA a barrier between dev and ops. But I'm curious, does product management fit into this equation, in this engagement model?
No, actually, that's a good question. It doesn't very much. At least at Facebook, it doesn't. Mostly because from an infrastructure perspective, we really focused on making a rendering layer and a data layer that's separate from the product. And so the product teams, mostly what they do is they build a lot of PHP and JavaScript to interact with the data itself. And so even though we don't engage directly with the product teams that are doing UI, we do have a set of teams in product land, which is what we call it, that does do infrastructure as well. So we engage with them. So our feed team, for example, what they do is they have an infrastructure component and then they have a product component. And so the production engineers that work with that team do interact directly with the product managers to make sure that what they're doing is not going to also hurt us. So, yeah.
So if you could go back to 2009, would you have actually put in place the SRO team, or would you have gone straight to production engineering teams?
No, we couldn't have done that. I would have done the same thing over and over again. Mostly because we didn't have the automation, we didn't have the right skill set, we didn't really have the right focus. Too many things were burning and on fire that if we had tried to go just straight into this model, things would have really, really broken more. So.
Hi. Great talk, by the way.
Thank you.
Very interesting. Can you speak a little bit about the change management process? You kind of didn't like that.
Yeah, sure.
Okay, so when something gets changed or deployed to production, who is responsible for ensuring there's what we call post-deployment verification and automating that?
Yeah. So it's a good question. Like I said, my philosophy has always been that if you deploy code to production, congratulations, you own it, right? And so if you're a software engineer that's doing that, then it's your responsibility to make sure that you actually are either A, automating it, or B, that you're paying attention to the things that are happening as you're deploying it. Now, that is the ideal situation, right? In reality, what ends up happening is that a lot of times people make mistakes. So on the production engineering teams, deployment is a big focus area for us. So we build a lot of tools that allow the software engineers to do that. So that's a lot of the functions of the automation that we do. And so we can do staged rollouts. We can do canary rollouts. It is a simple script that they can run. It gets a lot of feedback. We've helped them understand what to look at to figure out when there's a problem. And at the end of the day, like if they were the one pushing that button, quote unquote, and it didn't go well, then they're the ones that need to fix it, right? So,
Thank you.
Yeah.
Can you tell me a little bit about the relationship between the customer support team, the people who talk to the end users, and the production engineering in terms of access to tools, production bridges, root cause analysis?
Yeah, I mean, our customer support team really is engaged on things like, I can't untag myself, or I can't upload this photo, and I can't use this feature. So our customer support team does actually look at all these tools. They are open to them if they want to. Generally, they don't have as much knowledge about it, but we have trained a core set of people in customer operations that can look at these graphs and look at this information, and then come into IRC and ask us questions. And generally, they follow along on the side as well. We do have a separate program where when there are big incidents, we have an incident manager on call who actually then emails out to a small subset of people in the company that says, hey, there's this really big problem that's happening. You're probably going to get a lot of requests from other companies or press requests, or you're probably going to get a lot of customers who are going to complain about this. So heads up, this is happening. So we just try to automate the communication aspect of it to them. Last question.
How do you market all these tools that the production engineering group builds to the software developers? Like, how do they discover it? How do you publicize what these things are and how they work?
That's actually one of our biggest challenges, by the way. So, lead by example. When you actually have teams that are using these tools, you just bring them in and you show them how to use them, and you sort of indoctrinate the new software engineer to understand how to do it. When we're building a new tool, we use Facebook. Like, we actually have internal groups that allow us to publicize to everybody. I've seen some teams use ads inside of Facebook to market their own. Yeah, it's awesome. Like, we dog food our own services. Sometimes we target them to specific software engineers. Yes, exactly. Thank you. Yeah. Thank you, everybody.